Let us start with the namings first. This is the center of a circle, where all the points on the circle are at an equal distance from this point. Now, if we draw a line from the center to any point on the circle, this line is called the radius. The radius is the same for all points on the circle. If we extend a straight line across the circle, passing through the center, we get the diameter. The diameter is always twice the length of the radius. A line segment that connects any 2 points on the circle without necessarily passing through the center is called a chord. The longest possible chord of a circle is its diameter. A curved part of the circle between 2 points is known as an arc, while a sector is the region or an area between 2 radii and an arc. If a chord divides the circle into 2 regions, each region is called a segment. Now, the circumference of a circle is the total length of its boundary, or perimeter of a circle. Then a tangent to a circle is a straight line that touches the circle at exactly 1 point without crossing it. And a secant is a straight line that intersects the circle at 2 distinct points. Then we use the word subtended to describe how an arc or a chord creates an angle at a point on the circle. For example, when an arc forms an angle at the circumference, we say the angle subtended at the circumference by the arc. Similarly, if the angle is formed at the center, we say the angle subtended at the center by the arc. This completes the basic naming of a circle. Now, theorem number 1. Angles subtended by the same arc are equal. This means that if an arc subtends an angle at multiple points on the circle, all such angles are equal. So, this angle is equal to this, and this one as well. Now, if I draw another angle like this one, it will be equal to all of these angles. Now here's a question. If this angle is 65 degrees and this angle is 35 degrees, then what will be the value of all of the remaining angles? It's easy, right? This is 65 degrees, so this angle will also be equal to 65 degrees, because angles subtended by the same arc are always equal. Similarly, if this angle is 35 degrees, then this will also be equal to 35 degrees, following the same theorem. Now, the sum of all angles in a triangle is 180 degrees, so can you tell me in the comments, what will be this angle? Let us move on to theorem number 2. Angle at the center is twice the angle at the circumference, which means the angle subtended by an arc at the center of the circle. Or, this angle is always twice the angle subtended at the circumference by the same arc. So, if this angle is 40 degrees, then this central angle will be twice of it, or 80 degrees. But if I draw like this, then this angle will be 40 degrees using the first theorem we just saw. Now, theorem number 3. Angle in a semicircle is always 90 degrees, which means if an arc is a semicircle, that is, its endpoints lie on a diameter, then the angle subtended at the circumference is always 90 degrees. Using theorem 2, can you tell me why is this so? This is because we know that a full circle has 360 degrees, so half of a circle has 180 degrees. Therefore, this angle, which is subtended by this semicircle on the circumference, will be half of it, or 90 degrees. Right? Nice. Okay, tell me if this is the diameter of the circle, this side length is 3 and this is 4, then what will be the value of the diameter? Now, theorem 4. Theorem of cyclic quadrilateral. A quadrilateral is called cyclic if all its 4 vertices lie on a circle. The important property of a cyclic quadrilateral is that its opposite angles are always supplementary. This means that if we take any 2 opposite angles of a cyclic quadrilateral and add them together, the result will always be 180 degrees. For example, if this angle is 70 degrees, then this angle will be equal to 180 minus 70, or 110 degrees. Now, theorem 5. Theorem of tangent and radius. We have already mentioned that a tangent is a straight line that touches the circle at exactly 1 point without crossing it. The important property of a tangent is that it is always perpendicular to the radius at the point where it touches the circle. Now, Theorem 6, the two tangents theorem. If two tangents are drawn to a circle from a single external point, then these tangents will always be equal in length. Another important property of this theorem is that the line joining the external point to the center of the circle always bisects the angle formed between the two tangents. So, if this angle is 40 degrees, then both these angles will be equal to 20 degrees, and if this length is equal to 5 units, then this piece will also be equal to 5 units. Now, Theorem 7, alternate segment theorem. This theorem states that the angle between a tangent and a chord drawn from the point of contact is always equal to the angle that the same chord subtends in the opposite segment of the circle. Same is true for this angle. It will be equal to this angle because this chord makes this angle at the circumference of the circle. Now, Theorem 8, chord bisector theorem. This means that if we draw a line that is both perpendicular to a chord and divides it into two equal parts, then that line must pass through the center of the circle. Now, Theorem 9, equal chords, equal angles theorem. Suppose we have a circle with center O and two chords AB and CD of equal length. If we draw lines from O to the endpoints of both chords, then the angles AOB and COD at the center will be equal. Similarly, if we take any point P on the circumference and connect it to A and B to form angle APB, and another point Q connected to C and D to form angle CQD, then these two angles will also be equal. Now, Theorem 10, 2 seconds segment theorem. Suppose we have a circle and an external point P outside the circle. From P, we draw a second line that intersects the circle at 2 points A and B, and we draw another second line that intersects the circle at 2 points C and D. Then, according to the theorem, the product of the distances PA times PB will be the same as PC times PD. Awesome! We can extend this theorem and say that if this line is a tangent, say this line touches the circle at a single point C, then we have PA times PB equals PC square. This theorem is called the tangent-secant theorem, which is very similar to 2 secants segment theorem. Now suppose we have a circle and an external point, P, outside the circle. From P, we draw a secant line that intersects the circle at 2 points A and B, such that this secant line passes through the center of this circle. Then we draw this tangent, which touches the circle at C. Now, if PA is 3 units and PC is 4 units, then what will be the radius of this circle? We will solve it using 2 different methods. First, we will use tangent-secant theorem. Let us label the radius as r. So AB, or the diameter of this circle, will be 2r. Thus, PB will be equal to 3 plus 2r, right? Now, using this theorem, we get 4 square equals 3 times 3 plus 2, r, or 16 equals 9 plus 6r. Therefore, r equals 16 minus 9, or 7 over 6. We can also solve the same using the fact that a tangent is always perpendicular to the radius at the point where it touches the circle. So, this will form a right-angled triangle with the side lengths as 4, r, and the hypotenuse as 3 plus r, and thus 3 plus r, whole square, equals 4 square plus r square. Expand it to get this. R square gets cancelled out, and we are left with 6r plus 9 equals 16, or r equals 7 over 6. Now we move on to our final theorem, or Theorem 11, which is chord-chord power theorem. This theorem states that if 2 chords intersect inside a circle, let us label the sides as A, B, C, and D. The theorem says A times B will always be equal C times D. Let us end this video with this question. Suppose this is a cyclic quadrilateral in which these are its diagonals. If this angle is 55 degrees and this angle is 45 degrees, then what will be the value of this angle? Okay, using our first theorem, we know that the angles subtended by the same arc are equal. So, if this angle is 55 degrees, then this angle will also be equal to 55 degrees. So, this angle will be equal to 55 plus 45, or 100 degrees. Then we also know that the opposite angles of a cyclic quadrilateral are supplementary. That is, they add to 180 degrees. So if this is 100, then this will be 80 degrees, and that's it. Aren't circles cool? If you enjoy my videos and want to support my channel, consider becoming a Patreon, as it helps me create more awesome content for you. Link is in the description. Also, you can support my channel by joining our community and becoming a member. So good! Now click on this video to solve a very nice circle problem which will use many of the theorems discussed here.